Hi guys, it's Ben from Pragmatic Software Engineering, and today we're going to be talking about a really primitive but cool data structure called a stack. Now in this video, I'm assuming you've watched linked lists, because stacks are based off of linked lists. So if you haven't watched that, take a couple minutes and watch that video and come on back. It'll make this video a lot easier to comprehend. I'd like for you to recall linked lists. Now, what do linked lists provide us for utility as programmers? Well, linked lists allow us to have a scalable collection. And what I mean by that is the size of a linked list can change, where an array cannot. And that's because we've departed from this idea of a linear contiguous piece of memory backing an array to this idea of nodes that point to different addresses in the system. Additionally, linked lists, like arrays, pair wonderfully with loops. So if we take linked lists and have them in mind, when we talk about stacks, it'll be a lot simpler to comprehend. Today, we're talking about stacks. A stack is a linear data structure. Stacks can also be called first in, last out. In a stack, the youngest element is at the top of the stack. The stack only guarantees exposure of the top element of the stack. Now the stack interface, or the stack contract, is relatively simple. It's only around 4 functions: push, pop, peek, and is empty. A couple years ago when I was scrolling through Facebook looking at dank memes, I actually found a really great article that explained stacks really well. So if you have trouble understanding what a stack is, think of breakfast foods. Think of a stack of pancakes. And imagine, the cook comes out with a stack of pancakes and he's giving out the pancakes to the customers or to somebody. Each person has to remove the top pancake. They can't remove the bottom pancake. That just doesn't work, right? So if you're having trouble trying to isolate and understand what is a stack, think about pancakes. Let's start getting into the implementations of this contract. A stack supports something called a push. Now a push is, under the covers, an add at element 0. With a stack, when you push or you add a new element, and that element becomes the top of the stack. Think about pancakes again. You create a new pancake, you put it on top of the stack, right? This means that the stack's topmost element is the youngest element, and we can only access the youngest element. So if we want to go traverse through and get to the oldest element, we have to start removing things off of the stack. So I hope you've been noticing that data structures provide us utility in searching or getting or setting and things like that. But it requires us to organize and format our memory. When we add onto the stack, it's actually constant time. Think about it though. What we're doing is we're creating a node and we're inserting at 0, like a linked list. So we point the stack's head to this new node, and this node's next is the next thing in the stack. When working with the stack, you may want to actually get what is the top element and remove it. If you want to remove and return the top element of the stack, you'll use the function pop. The pop function takes the topmost element, removes it from the stack, and returns it. The runtime of popping is constant time. As just a note here, I want to tell you that in certain languages, when you pop from an empty stack, you'll get some sort of exception. So be careful when you're popping. Now, let's say for some reason you want to see what the topmost element is in the stack without removing it from the stack. You will then use the function peek. Peek gives us the value of the topmost element in the stack without really removing it from the stack. You can also ask the stack if it's empty. This is a constant time lookup. The utility that this function provides is used when you're popping from the stack. In certain languages, as I've underscored before, certain languages will throw an exception if you attempt to pop from an empty stack. So it's very common you'll see a check of stack.isEmpty right before you pop. So that's a stack. It's actually a pretty easy data structure to get your head around because, well, let's face it, we all like breakfast, we all like pancakes. And if you don't, there's something wrong with you. Anyways, I hope you liked this video. Please share it with your friends, like and hit that subscribe button.